Hey everyone, this is number 4 from Mixture Madness. So Mixture Madness, number 4. Okay, essentially we have a coffee merchant and he wants to sell a 6-pound blend of premium coffee, so a 6-pound mix that costs $5 per pound, and he's going to use a $6 per pound grade and a $3 per pound grade of coffee. How many pounds of each should be used? All right, I'm filling out my chart. Okay, we have the unit value, or UV if you want to be super short. We have the quantity, sorry about my handwriting, Q. And then we have the total value, so TV if you're dying to use those shortcuts. All right, I know that we have, I'm gonna make it like this. We have the cheap coffee, we have, seems to be an expensive coffee, and then we have this mix, this, excuse me, I should have written blend, so forgive me. All right, I'm looking at the problem, and it looks like we're gonna have a 6-pound blend. So the total of this mix is 6 pounds. Oops, I shouldn't have done that, forgive me. 6 pounds, the quantity is 6 pounds. Well, I don't know how much of the cheap and I don't know how much of the expensive, so let's get a variable. Let's do X for cheap, and then 6 minus X is what's left over, because X and 6 minus X is 6. This is that additive inverse. They cancel out these X's, so we end up with just 6, blah, blah, blah. All right, so that's what we're dealing with in terms of quantity. It seems that the cheap, based on the problem, is $3 a pound. And the expensive one, based on the problem, is $5 a pound. No, I'm sorry, $6 a pound. And this mix, this blend, is gonna be $5 a pound. So now we have to multiply across. We're gonna multiply across. Let's see, and we're gonna have an equals there. 3x is 3x. 6 times 6 minus x, I don't feel like doing that yet, but it's going to be distributive. And then 5 times 6 is 30. Now we take these two numbers and we add them together, and then this is our total. So my equation is gonna be 3x plus 6 times 6 minus x equals, sorry about this mess here, 30. Oh, distributive, 3x plus 6 times 6 is 36. Bring down the minus, 6 times x is 6x, equals 30. Ugh, I got some like terms that are not so nice. We have negative 3x plus 36 equals 30. I'm going to subtract 36 from both sides. So negative 3x equals negative 6. Ooh, I'm going to divide both sides by negative 3. And x equals 2. Oh, you know what I didn't do, which I'm so annoyed about? I'm embarrassed about? X equals pounds of cheap coffee. Remember that? X was pounds of cheap coffee. So, how many pounds of each? The question, we have to answer the question, which is how many pounds of each of these grades should be used? Well, up here we had X. Oh, well, we just found out X is 2. So now we know 2 pounds of cheap coffee. Possibly I should have written pounds up here, and I should have, and that's good. So, and then what's 6 minus X? 6 minus 2, it's 4, and that makes sense because 2 plus 4 is 6 total. We nailed it. So that's 2 pounds of cheap coffee and 4 pounds of expensive coffee. We can do this. It's totally doable. The chart will help. Unit value, quantity, total value, and then we make our equation with this third column. All right, good luck, kids.